Today we are going to learn about the atomic structure and the periodic table. As we said before, everything you see around you is made out of tiny particles. These tiny particles are the atoms. Over 200 years ago, the scientist John Dalton developed his atomic theory. He stated that the atoms of any one element were identical. So he said the atoms of any one element were identical and each atom was indivisible. So the atomic theory, according to John Dalton, is that the atoms of any one element were identical and that each atom was indivisible. However, in the last 100 years, it has been proved by great scientists such as Bohr, Einstein, and Henry Moseley that the atoms are made up of even smaller subatomic particles. So, according to these scientists, there are subatomic particles. The most important subatomic particles are the protons, the neutrons, and the electrons. Here we have a diagram of an atom. As we can see, we have here the center of the atom and we have here the energy levels or the electron shells. The center of the atom is called the nucleus, and the nucleus has the subatomic particles, the protons and the neutrons. And here we have the electron shells, or we call them the energy levels, in which the electrons move. The protons and the neutrons are very dense and they occupy a small volume of the atom, only here the center of the atom. What about the characteristics of the subatomic particles, the proton, the neutron, and the electron? Each subatomic particle has a symbol. Proton is P, neutron is N, electron is E. The proton is positively charged, the electron is negatively charged, while the neutron has no charge. What about the mass of the subatomic particles? As we can see here, the mass of the subatomic particles is measured in a unit called the atomic mass unit. The proton and the neutron have a similar mass, while the electron has a very little mass. So the mass of any atom depends on the number of protons and the number of neutrons in its nucleus. This is a model of a helium atom, and the key here represents the subatomic particles. We have here the protons. These are the protons, and these are the neutrons, and these are the electrons. How many protons are here? Here we have 2 protons and 2 neutrons and 2 electrons. How are the electrons held in the shells within the atom? The electrons are held by what we call electrostatic force of attraction. Electrostatic force of attraction. Between what? Attraction between what? Between the electrons themselves and the positively charged protons in the nucleus. So we have here electrostatic attraction between the positively charged protons and the negatively charged electrons. That is how the electrons are held in the shells within the atom. What about the overall charge of the atom? The overall charge of the atom. What is the charge of the atom? The atom is neutral. The atom doesn't have a charge. What do we mean by neutral? no charge. Why no charge? Because the atom has equal number of protons and equal number of electrons. In other words, the number of positive charges is equal to the number of negative charges. That's why the atom is neutral. Now let's learn more about the energy levels, in other words, the electron shells. What are the energy levels or the electron shells? They are regions around the nucleus in which the electrons move. So here we have the nucleus, and around the nucleus we have the energy levels in which the electrons move. We can draw the electrons as dots or as crosses. We have 7 energy levels, and scientists use a single capital letter for each energy level. So we have K, L, M, N, O, P, and Q. As we can see, as we go far from the nucleus, the distance between the energy levels gets smaller. And electrons in the innermost shell are least energetic, and those in the outermost shell are the most energetic. Each energy level can hold only a fixed number of electrons. And according to this syllabus, the only electron configuration that you should know is the 2882 rule. Because later on in the AS level, you will get to know more about the electron configuration and different theories. This is how the elements are represented in the periodic table. If we take lithium as an example, we will find that X represents here the symbol of the element, and Z represents the proton number, or we can call it the atomic number. The atomic number is considered the ID for each element. What do we mean by this? Each element has its own proton number, and no two elements have the same proton number. So for example, here lithium has a proton number of 3. This is only for lithium. No other element can have the same proton number, which is equal to 3. And A here represents the nucleon number. In other words, we can call it the mass number. The mass number is equal to the number of protons plus the number of neutrons. So here regarding lithium, lithium has an atomic number of 3. So how many protons does lithium have? Lithium has 3 protons. What about the electrons? 3 electrons as well. What about the neutrons? How to calculate the neutrons? We know that here the proton number is the number of protons. So Z is equal to the number of protons. A is equal to the number of protons plus the number of neutrons. So how to find the neutrons? Neutrons is equal to A minus Z. This is how we get the number of neutrons. So it's equal to 4. Let's work out another example. For example, we have magnesium, Mg, 12, 24. 12 is the proton number. The proton number is 12. What about the number of electrons? Also 12. As we know, the number of protons is equal to the number of electrons. What about the 24? The 24 is equal to what? Is equal to the protons plus the neutrons. So can we find how many neutrons? Yes. We apply the formula A minus Z. A is equal to 24 minus 12 is equal to 12. So how many neutrons are there in the magnesium atom? 12 neutrons. Now let's practice drawing the electronic configuration of different elements. Lithium. Lithium has 3 electrons. And we studied the 2-8-8-2 rule. So how to draw the electronic configuration here? In the middle, we write the symbol of the element, and we have here 3 electrons, as we said. The first energy level can hold up to 2 electrons. So we have 2 electrons in the first energy level. So remaining 1, the other remaining electron will be in the second energy level. So this is how to draw the electronic configuration. What about the sodium? Sodium is 1123. How many electrons does a sodium atom have? It has 11 electrons. So let's draw together the electronic configuration of sodium. We put here the symbol of the element. As we said before, we can represent the electrons either by drawing dots or crosses. So let's take the crosses here. The first energy level can hold up to 2 electrons, so 2 electrons. What about the second one? The second can hold up to 8 electrons, so now 10. So 1, 2, 3, 4, 5, 6, 7, 8. Remaining how many electrons here? 8, 9, 10. The last energy level will contain only 1 electron. So here we have 11 electrons, and this is how we write the electronic configuration. This year, enough for you to know only the electronic structure of the first 20 elements, up till calcium only. Let's draw together the electronic configuration of some elements. We have here boron. Boron has 5 electrons. How are we going to distribute the 5 electrons? We have 2 and 3, 3, 4, 5. So we write the symbol of the element. The first energy level has 2 electrons, while the second energy level has 3 electrons. What about the oxygen? 8 electrons. We can distribute them 2 and 6. So we write O here. We have 2 electrons here and 6 electrons here. 1, 2, 3, 4, 5, 6. What about the fluorine? F9. The first shell can hold up to 2. Remaining how many? 9 minus 2, 7. So we write F. We can use the crosses here. We have 2 electrons in the first shell and 7 electrons in the outermost shell. 1, 2, 3, 4, 5, 6, and 7. What about the neon? Neon has 10 electrons. 2 electrons in the first shell, and the second one can hold up till 8, 9, 10. So we write here Ne. So 2 electrons here, remaining 8. 1, 2, 3, 4, 5, 6, 7, and 8. Let's practice more examples together. Here we have phosphorus 1531. How are we going to distribute the electrons? 15 electrons we have here. The first shell will take up to 2. The second one will take up to 8, 8, 9, 10. Remaining 5, so it's 2, 8, 5. Write the symbol P. 2 electrons here, 8 electrons here, the second shell, and 5 electrons in the outermost shell. Argon 1840. Argon 2, 8, 8, 9, 10. Remaining 8, 8. So argon Ar, 2 electrons here, then 8 here, and 8 in the outermost shell. Calcium 2040. We have 2, 8, 8, 9, 10. Remaining 10, 8, and 2. Calcium Ca, 2 electrons here, then 8, then 8, then 2 electrons in the outermost shell. After studying the electronic configuration of different elements, we found out that there is a correlation between the group number and the number of the outer shell electrons and the period number and the number of the occupied electron shells. For example, here we have group 1 elements and group 2 elements, group 3 elements. What was the electronic configuration of lithium? It was 2-1. What about sodium? It's 2-8-1. Potassium 2-8-8-1. As we can see here that the number of the outer shell electron is equal to the group number. What about group 2? It starts with the beryllium. Beryllium is 2 and 2. Magnesium 2-8-2. Calcium 2-8-8-2. So here also the group number, which is 2, is equal to the number of the outer shell electrons. Also group 3, we have here 2 and 3. Aluminum 2-8-3. Here also the group number is equal to the number of the outer shell electrons. We will find this up till group 7 elements. What about group 8 elements? Group 8 elements are called the noble gases. All these gases have full outer shell. As we can see here, helium has 2 electrons in the outermost shell, which is a full shell. Regarding neon, it's 2-8. Regarding argon, it's 2-8-8. So all the noble gases have full outer shell. That's why they are inert gases. What about the period number? Here we have period 1, and this is period 2, period 3, and period number 4. The number of the occupied electron shells is equal to the period number. For example, here, this is period number 2, and here we have 2 occupied electron shells. Here, sodium is in period number 3. And the number of the occupied electron shells is equal to 3. What about potassium? Potassium is in period 4, and the number of the occupied electron shells is equal to 4. Now we are going to learn about ions. What is an ion? An ion is an electrically charged particle. How is it formed? It's formed when an atom loses or gains one or more electrons. What do we call this process? This is called ionization. So when an atom loses or gains an electron, an ion is formed. When it loses an electron, it becomes positively charged. When it gains an electron, it becomes negatively charged. We call the positively charged ion cation, and we call the negatively charged ion anion. For example, potassium. When potassium is involved in a chemical reaction, each atom loses an electron to form a positive ion. So potassium loses 1 electron. As we know, potassium has 19 protons and 19 electrons. So it has 19 positive charges and it has 19 negative charges. When potassium loses 1 electron, now it has 18 electrons only, which is 18 negative charges, and still the number of protons is the same. So what is the overall charge? The overall charge is positive 1. Another example, the oxygen. When oxygen is involved in a chemical reaction, each atom gains 2 electrons, and it becomes a negatively charged ion and anion. As we know, oxygen has 8 electrons and 8 protons. In other words, 8 negative charges and 8 positive charges. So when it gains 2 electrons, it has now 10 negative charges and still 8 positive charges. So the overall charge is 2 negative charges. That's why the oxygen is an anion. Another example here, the sodium. Sodium is 1123. This means that sodium has 11 electrons and 11 protons. In other words, 11 negative charges and 11 positive charges. When sodium is involved in a chemical reaction, it tends to lose 1 electron to form a positive ion. So from sodium, the neutral atom, into sodium positive ion, this means it has lost 1 electron. So what is the overcharge here? Losing 1 electron, so now 10 negative charges and 11 positive charges, so the overall charge is 1 positive charge. The other example here is the sulfur. Sulfur is 1632. Sulfur has 16 protons, 16 electrons, so 16 positive charges and 16 negative charges. When sulfur is involved in a chemical reaction, it tends to gain 2 electrons. Gain 2 electrons and becomes a negatively charged ion. How did we get this overall charge? Now, gaining 2 electrons mean 18 negative charges and still 16 positive charges. So what is the overall charge here? 2 negative charges. Here we have a table for some common ions. Like lithium, lithium loses 1 electron and it has 1 positive charge. Sodium as well, potassium, magnesium tends to lose 2 electrons as well as the calcium. Aluminum tends to lose 3 electrons. These are examples of some positive charges. Here the fluoride ion, the chloride and bromide and so on. They tend to gain electrons when they are involved in chemical reactions. Bromine forms bromide ion, chlorine forms the chloride ion, and so on. Some ions here in this table contain more than one type of atom, like the ammonium ion, NH4 positive 1, like the hydroxide ion, OH negative 1, like the carbonate ion, the nitrate ion, and the sulfate ion. We call these ions polyatomic ions. What do we mean by polyatomic ions? This means that these are ions that contain more than one type of atom. By this, we are done with subtopic 2.2, which is the atomic structure and the periodic table. Thank you for watching.